Hi everyone. So in this video we'll discuss about the LangChain LCEL concept. Last time we have discussed about LangChain building code building blocks, and we have discussed about the model, prompt, and parser. So these are the three basic building blocks of the LangChain concepts. Uh, and we have discussed in the latter part we will discuss more about the examples of more practice session about the code building blocks, but uh, in this session we will discuss about the LangChain LCL concept. Basically I want to cover more topics so that we have a uh, bunch of concepts to discuss during the practice sessions. Okay, so let me share my screen, and I'm going with the concept of LangChain. Okay, so yeah, so this is the episode 3, and where we are going to discuss about the LCL and orchestration. So basically last time we have already pointed there are three main things about LangChain, that is the prompt, modal, and parser. Inside the LCL also, this is the basically not this is the only the concept here. For the whole LangChain concept, these are the three building blocks, and on these three building blocks whole the concept has been laid. So again I'm going from top to bottom, sorry, bottom to top, and I'm going to discuss about discuss about this orchestration part, where we are going to discuss about the LCEL runnables and composition, sorry. So basically what does it mean, orchestration mean? So orchestration mean to say that when how LangChain is working. So basically user give the input, that is basically the user request. Then uh, how we can be able to send that request to the model in the form of prompts. So we are just preparing the we are preparing the instructions. Then after preparing the instruction, we send that instruction to the model, and once we will send these things to the model, then model generate the response, and then after we got the output as a return result. This is the normal concept of the LangChain. Now basically orchestration decides how component pass the data, execute, branch, and combine everything has been decided during this session, during this part. So basically if I'm talking about, if you are a software developer, then you can be able to think like when you are giving some input in the in software analogy, we are giving some input, then that input will be validated. Then after validating that input, we will process those things. After that we will store inside the database if you are making the post request, and after that we got the response. And similarly if you are looking for the fetch request, then at first we will verify that input, validate that input is valid or not. On the basis of that we make the process on that input. Maybe if I am passing the user ID, then from that user ID I can be able to uh, fetch other details, so that from the desired table I can be able to get the desired output also. So this is the software analogy. In the AI analogy, we can be able to say that it is normal that from the beginning we are discussing about we need to give the prompt. We need to prepare the prompt. After the preparing the prompt, uh, we will call the model, and after getting the response from the model, we are just passing those data to represent on the application side. So we can be able to say that there is a prompt, model, parser, or a application. These are the basically the components we can be able to say. Now what is LCL? So LCL mean to say that LangChain Expression Language, and it's the basically a declarative way to compose the components. and what does it mean? So basically, how we can be able to flow, how we can be able to do the flow, how we can be able to uh, declare the flow so that we can be able to get the desired output. Whatever the we are expecting, that output we can be able to fetch from there. So basically, it does mean that one. Now LCEL, the LangChain Expression Language. Here we have the that we have already discussed. We have a prompt, and that is the input format. Then we encounter with the model, and here we are giving the prompt, and from the model we are expecting the response. After getting the response, we come across the parser, and parser basically parsing our data and return the response um, in the application format or the user format, whatever the format that we want to show on on our application side. So this is the basically the chain, uh, and and this is the most important concept. So basically, if you are using the LCEL, then there are multiple and inside of the LangChain, if you are going with the LCL concepts, so everything is runnable. Mean to say, prompt is our runnable, model is our runnable, parser is our, everything is runnable. If you are going with the LCL concept, everything is runnable. We can be able to assume that every concept is runnable, like a runnable. And when we are there are multiple types of runnables. Runnables like RunnableSequence, RunnableLambda, RunnableBranches, RunnablePassthrough, a lot of Runnables concepts. These are the few important concepts. So, and this pipe operator, it's similar to the Unix pipe operator. And what it does mean, the Unix pipe operator? So basically, Unix pipe operator, what it does? So basically, input of one uh, will be considered as the output of the second. Sorry, output of first one is be taken as the input of the second one. So mean to say, uh, whatever the output of prompt given as the input of model, right? And whatever the output of model will be given to uh, input of parser. Output of model is given to output of parser. Sorry, output of model is given to input of parser, right? So this is the basic concept about the LCEL. Now we are giving here the same concept. What is the runnable? The common abstraction that makes the LangChain components composable, right? The common abstraction that make the LangChain concept composable. Composable, yes, composable. Now composable, yeah. So basically, here we are giving the input, and here is our runnable. Basically, when we are giving the input, here we are receiving the input, perform the operations, and returns the output. This is the output. Now here is one more concept. uh, mm, here the same thing that I have already discussed. Inside the runnable, everything inside the LCL, everything is runnable. Prompt is runnable, model is runnable, parser is runnable, function is runnable. Everything will be considered as a runnable inside the LCL concepts. Now, and it is a sequence, and sequence will be considered the same thing. Like output of A will be considered as an input of B, and output of B will be considered as an input of C. So prompt, here we are giving the we are creating the request. From model we are generating the response. Parser format the output, and then after that we got the result. And here is the it is the basically the runnable sequence where we are using the pipe operator for representing the runnable sequence. We are using the pipe operator. So and in the manual approach that we have already done for the during implementation of the LangChain code building block, we are using the manual approach where each component separately and pass output yourself. So basically we are calling the each component separately, but inside the LCEL described the composition once, then invoke the workflow. So basically here during the example I will explain what it does mean. It describes the composition once. At first we need to define the composition of all the runnables, then after we will invoke the workflow. Now what does mean the runnable parallel? Runnable parallel mean to say that uh, at first we have discussed about the runnable sequence. This is the different part that is called the runnable parallel, and inside the runnable parallel uh, uh, two independent workflows from the same input and combine their combine their output. Mean to say, suppose if I'm talking in terms of agents, so I have agent 1, I have agent 2, right? And 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 I have given the same input to agent 1 and same input to the agent 2, and both agents are running parallelly. Suppose if I want to given some input, and at first I want to write those input I have given to the agent, and the purpose of that agent is to convert that from that input, just write the text, and after during writing the text it is also validating suppose the spelling check or grammar check, right? So both working parallelly, both agents are working parallelly, or suppose the summary chain, there is one agent that is working as a creating the summary from my input, and the second agent from the same input it is generating the question, right? So I have given the same input, and from the same input my one agent is generating the summary, and my second agent is generating the question, and both working is worked parallel. Then after the output of both, we are combining those output, and as a final result we got the summary plus questions. So runnable parallel is useful when the branches are independent. Mean to say, from the same data I can be able to generate the summary, and from the same data I can be able to generate the questions also. So in that case we can be able to use the runnable parallel. Runnable pass through or runnable lambda. Runnable pass through mean to say that when uh, along with our prompt, if we need to send some extra context to our agent, then in that case we can be able to say that we can be able to use the runnable parallel, right? So basically it is the same meaning, that is when we want to carry the original question another result alongside another result. Runnable lambda mean to say that if we want to implement some our own logic, um, if we want to implement some our own logic, then in that case runnable lambda will be comes under the picture. Suppose uh, I have a I will demonstrate that example also during the example session. So basically suppose ki I have called my model after giving some instruction prompt. After the whatever the output that I'm getting, I want that output inside the uppercase, right? In that case we can be able to say that runnable lambda will be used. So basically it's creating a custom logic, or it is helping us to implement our own logic. Runnable branch. Runnable branch mean to say we are giving the input user request condition. Here is the condition. So suppose if I'm giving some if I have a agent, yeah, I'm talking in the terms of agent. I have a agent 1 and I have agent 2, and agent 1 has some different feature, agent 2 has some different feature. Suppose agent 1 is capable to agent 1 is capable to I can be able to say agent 1 is capable to register the patient, and agent 2 is capable to identify that that patient has been visited earlier or not, right? So when we are giving the input, and if that basically at first agent 1 we can be able to consider as agent 1 is focusing on if some patient is coming, then it at first checking that the patient is appearing at the first time or not. If it is not, then or we can be able to consider some other examples also. So basically it's uh, something like it's contains some conditions, and based on that condition it's work. So for example yeah, I can able to go with one example. Suppose I have created one agent, and uh, I am giving the prompt, and on the basis of prompt it is basically deciding which agent is should be called. Suppose I have a chatbot, and inside that chatbot I have two different resources for giving the response. Like some of the resources is coming from my SharePoint, and some of the responses is coming from my DB. And based on my prompt, it is basically deciding which agent should be I need to select, right? So in that case we can be able to use the conditional runnable branches. So based on our prompt, it basically decide in which branch I need to relocate, I need to locate, and on the basis of that it is calling the agent. So this is the concept of the runnable branches. And if you're talking about the whole picture of the runnable mental model, so there is a sequence where the input of A goes to input as a output of A goes to as a input of B, output of B goes as a input of C, and the final result will be as a sequence. We can consider parallel. Both are independently working. Pass through keep the original input along with some other input if you are trying to do. Enable lambda, so basically run my custom function, right? And runnable branches choose the workflow. uh, and these are the building blocks for the larger AI application, larger AI workflows, right? So here, so from component to and workflow, so now we can be able to think that a user asks the questions, prompt prepare for that one, prepare the instruction, then model generate the answer, generate the response, parallel give the multiple views if we have, and just like I have given the example that uh, it can be able to um, it can be able to summarize the context, summarize from the input, and can be able to generate the answer also. So both has different views and output, and combined we are getting the output appear in the RAG also. So during the discussion of RAG, we will discuss about these things also. So now we will go on VS Code and do with some examples. So key takeaways. So basically it is the same thing. LCL, a declarative way to compose the LangChain components. Runnable, a common executive abstraction with the input, operations and output that I have discussed. It's a basically little bit a technical term, but we need to think in the terms of that key what we are going to do, right? So now I'm opening my VS Code and going with some examples. So see, here. Yeah. So basically, here I have loaded all the packages. I have loaded the ChatGPT, Chat OpenAI model as a model. Uh, Here I have load the chat prompt template, and here I have loaded the output parser. Right now, now I'm going to load the model. So see here. I have just passed the that I have already discussed about this thing. So there is nothing new here. Here I'm just defining the prompt. So basically I've defined the I'm using the uh, mm, chat prompt template. So inside the chat prompt template we can be able to define the user and system prompt also. So inside the system prompt, whatever the system how the system should be behave, we are defining that one. And the user prompt, we are just asking the questions as a user point of view. Now this is the parser that I have already defined it from the output parser. LangChain core, it contains in the LangChain core package. So now if I am executing this one, so basically here the concept is occurring as a LangChain sequence. Here the concept is LangChain sequence. Like output of prompt will be considered as the input of LLM, and input output of LLM should be considered as input of str, right? So on the basis of that, if I'm trying to execute this mm, this, then yeah, see, this is the final output, right? So during this video we will wrap up this one because it's become longer. Inside the next video I will discuss a little bit more about the LangChain LCL concepts with some more examples. Like we will go with the LangChain Lambda, RunnableLambda, RunnableParallel, RunnableSequence. We have already covered RunnablePassthrough. So we will go with some examples, and then after we will go for some next concept about the knowledge layer. Right? Thank you. Till then, bye. And if you have any concern related to this concept, and if you are missing concepts, or if you are facing some issue, then you can be able to ping me here inside the chat the concepts for further. Thank you.